All right, I just want to go ahead and go over a few graphing problems just to review some things, parent functions and so on. So this first one we're going to graph is y equals x plus 2 squared minus 3. First thing I always like to do is remind myself what the parent function or the shape of the graph will be. Since it's squared, our parent function is x squared, which is in the shape of a parabola or a U shape. So that's what our final graph should also look like. From there, I also like to figure out what shifts I have in the graph. So right here, anything that's inside always affects your x values. So in this case, it'll be a horizontal shift, which I'm just going to abbreviate to HS, horizontal shift. It's going to go to the left too. Horizontal shifts always go the opposite direction. I always like to think of it as whatever makes this expression 0. So left 2 means it's going to be a negative 2. Like I said, to the left. We also have a vertical shift of negative 3. That tells me I need to move my graph down 3. So I'm going to go left 2, down 3. I like to put a little indicator of where that would be if I shift from the origin left 2, down 3. Then from there, if you just know your key points, so in this case it would be negative 1, positive 1, 0, 0, 1, 1, and 2, 4. Now, these are not the values I'm going to plot, because remember, I have to shift all of those to the left 2, down 3. So I can go from here, though, and this is kind of like a fake origin for me. This negative 1, 1 just tells me to go left 1, up 1. And then 0, 0 is right on that value. 1, 1 tells me to go right 1, up 1. And then 2, 4 tells me to go right 2, up 4. And I can reflect that point over my line of symmetry, since it's a parabola. And then I just connect those points in that parabola shape. Now let's just do a couple others just as refreshers. So this one right here, it's a square root function, which tells me the graph will look like a sideways half parabola. Now, there is a shift to the right 1. Remember, it's a horizontal shift. If anything inside affects your x's, and you always go the opposite. So it's right 1. So it's positive 1, moving to the right. There's no vertical shift since we're not adding or subtracting anything outside of the function. So we're going right 1. I'll just make an indicator there. Now there's one more piece that will affect our graph, and that's this 3. That, since it's on the outside, once again affects your y values. I call it a y distortion. Other people will call it a vertical stretch. So what you do, and the reason I call it a y distortion is to remind myself it's affecting my y values. I'm going to multiply all my y values by 3. So my key points are 0, 0, 1, 1, 4, 2. This just multiplies your, it triples your y values. So 0, 0 will stay 0, 0. 1, 1 will be 1, 3. We multiply the y value by 3. And then 4, 2 will be 4, 6. Now remember, these are not the coordinates I'm plotting. I'm shifting them all to the right 1. So I'm going to go ahead and do that. If I pretend this is like a fake origin, I'd be like 0, 0 right there. 1, 3 tells me to go right 1, up 3. And then 4, 6 tells me to go right 4. Oops, 1, 2, 4, up 6. Awesome. And then you just connect it so it maintains the shape of that parent function. Now, let's say you're in a testing situation. You think you've done everything right, but you'd like to double check. So before I do this last one, I just want to review that you can always use a table. In fact, you can always graph these with a table. But if you want to use this quicker method using key points or whatever, that's the way you do it. But the table method always allows you to either plot it or just double check your work. So this is how I could do it. This coordinate right here is at 1, 0. That tells me if I plug 1 in for x, I should get 0 for y. So I just plug it in. 1 minus 1, square root of 1 minus 1. If I solve that, I do in fact get 0. And you can try another one. So this is the coordinate 2, 3. So if I plug in 2 into my function, you get 3 times the square root of 1, which is 3. Okay, so it's just a way to double check that you've done things correctly. So let's go to our last one. I'm going to erase this just so I have room for my last one. This one is using an X distortion instead of a Y distortion. I guess I should first talk about the shape of the graph. Since it's a cube root, it's going to be your stretched S shape, like so. This -1 at the end, since it's on the outside, affects your Y's, which is why it's a vertical shift, and we're going down 1. So I'm just going to put an indicator right there. Now this 2 inside, it's inside, so it affects your X's, which is why it's an X distortion. Now remember, X distortions, you always do the opposite. So I usually say the X distortion is 2. I guess since I'm doing opposite, I'm going to go ahead and write the reciprocal, so it's a half. So we're splitting all of our X values in half. So our key points are typically -1, -1, 0, 0, 1, 1, and 8, 2. So cube root of 8 is 2. And all I need to do is divide all of those X's by 2 or multiply them by a half, however you want to think about that. So it'll be -1/2, -1. Notice I'm only touching the X values because it's only affecting the X values. Then 0, 0 stays the same. Then we have 1/2, 1, and then 4, 2. Once again, remember, these are not the coordinates I'm plotting because I got to shift all of them down 1. So I'm going to go left. This -1, 1, 1/2, -1 tells me to go left a half, down 1. Then 0, 0. Then up, or right a half, up 1. And then right 4, 1, 2, 3, 4, up 2. And then as long as you know your shape, that's plenty. You should be able to show the correct shape. And there you have it. That's just some basics of graphing.